chance. Chance, so when I talk about chance a lot because reliability and chance are tied together like brother and sister. Chance of failure is 1 times minus the chance of success. You know, if success is perfect, then that's 1 and chance of failure is 0. So perfect reliability means no failure. Well, we aren't there yet, but what we do know is the chance of failure, the chance of success is reliability. So I can now tie reliability up with chance of things going wrong. If I can drive this number, reliability, up very, very high, then my chance of failure goes very, very low. So I can begin to manage reliability by understanding where are the problems. If I roll the dice and I get two ones here and those two represent a failure, then what can I do to ensure that those failure situations don't arise? If they aren't there to have an opportunity to fail, then it can't be a failure. The machine carries on going. So this concept of chance and managing chance becomes very important because reliability is the chance of success. If I want to have high success, I've got to have high reliability because the two are linked. So whatever takes away, whatever affects reliability and lowers that, I've got to stop that. I've got to find it and stop it. Then I have created a higher chance of success, which means eventually the failure rate will decrease. Doesn't mean it's going to happen overnight. Now, some of these things take months to come through, but if I'm doing the right things to begin with, the right results come out at the end. So I want to start with what are the right things, and start doing the right things because they will pay off down the track. Okay, so what are the sort of things that are opportunities for lack of reliability? Poor balance, wrong fits and tolerances, wrong tension in fasteners, shafts that aren't aligned or shafts that are loaded up and stressed, rubbish in our lubrication. These are all opportunities for things to go wrong. It doesn't mean because they are there it will go wrong. It just means whether they are there, there's a chance it'll happen. If there was no problems with fastening, if my shafts were correctly in line, if there was no contamination, then the opportunities would not be there. The chance of failure, much, much less. So if I can manage contamination and prevent it, manage alignment and ensure it's correct, get the right fastening, get the right correct fits and tolerances, get the correct balance, I will cause reliability. I will decrease the chance of failure. So now we have our risk equation. Risk is typically consequence times chance is what most people see it in the books. This is a situation that Einstein warned us about. One of his advices was to make things as simple as possible, but no simpler. And I think the mistake we've made with risk is we've made it so simple we've actually missed the real meaning of what risk is, because this equation here has dropped off one factor in risk. The full equation of risk is consequence times the frequency of opportunity times the chance of failure at each opportunity. What this equation has done is dropped off this opportunity word. It doesn't show us there are actually 3 factors that affect risk. And this chance of failure is actually 1 minus reliability. There it is, chance of failure, 1 minus reliability. So I have now tied reliability back to risk. High reliability and this risk of failure is reduced. If my risk of failure is high, my reliability is going to be low. So if I can manage opportunity and prevent that by everything being right, then as a consequence, opportunity gets smaller and smaller. If I can ensure reliability by making the right choices, by installing things correctly, by running things correctly, then these 2 factors can't work together and the risk of failure drops lower and lower and lower. And that risk of failure falling means my uptime increases, my throughput increases, my costs are reduced, all the things we want to see happen. So yeah, that's why I'm confident. It's not going to be impossible to get these outcomes because all of these are controllable. Once I set the standards that deliver high reliability and meet those standards every single time, then I will produce those results. Now, risk is something that is a factor in plant wellness we want to measure. We want to measure risk in some sort of financial way, and we've done that. This sort of graph here typically is what we use. We can use a cost scale on one side and then a frequency of failure scale on the other. We can actually quantify risk from historical evidence. What this is saying is a couple of things. All of us have a risk boundary. You drive a car? You drive a car? Do you know what? People die on the road from driving cars. So you're going to drive home from this place? Anyone? Yeah, we all accept a degree of risk, even though we can die tomorrow on the way home. So companies are the same. We will accept a degree of risk and do nothing about it. We're going to let the dice roll and just pray the dice falls the right way. But knowing full well they might go the wrong way, in which case, shucks, what a shame. Now, that risk boundary is very important because in that area there, nobody will do anything. Managers won't move, CEOs don't care, nor do you and I. So that's human nature. I've got to know this risk boundary for every company because out of that risk boundary, people will move. It's too much risk to carry. We understand the implications of that. So I've got to make sure when I speak to companies and managers about risk that they understand the full size of the boundary they're talking about, how big a risk they're actually carrying. Because when we have a breakdown, that breakdown is going to cost money to fix. It'll be maintenance time, maintenance cost, it'll be downtime for the plant, it'll be opportunity lost, money we don't make because the parts that we would have made aren't there to make to be able to sell. So there's a whole lot of money lost when we have a breakdown. And so when I build this risk boundary for companies, I've got to find every single cent that they lose and that they miss out on making had there been no failure. And my experience is that when I look at how to do that, I can work out a ratio between the cost of direct maintenance versus the total cost to the business of all the losses and costs. If I can get direct maintenance cost, that's easy. That comes out of my computer system. Easy to get those numbers. To get the total business-wide cost, not so easy because there are so many unknown factors. How many sales could have you made but actually weren't made? You don't know that. But there's a way of allowing for those. What I found is when I do that calculation, when I do the calculation between direct maintenance cost and total business-wide cost, typically it falls in between a range of 7 to 15. Direct maintenance cost of $1,000, depending upon the process and the company involved, company-wide may actually mean a $7,000 cost or loss, up to $15,000 cost or loss. So I sort of said to keep things simple, let's call it 10:1. For $1,000 direct maintenance cost, the business loses $10,000 on all the costs and losses that it's incurred. So now my risk boundary isn't the direct maintenance cost only, it's actually the total money the company's lost. So when a maintenance repair costs $10,000 on the books, the business actually lost $100,000. And $100,000 has more meaning than $10,000.
Is that difficult to get a company to acknowledge that extra cost, beyond the maintenance cost? Because in some sense, it makes them look negligent because they've been ignoring these.
It's hard to find how much sales we would have made, we didn't make them. They are nebulous figures. So yeah, to get an exact figure is not so easy. To get this ratio, what I actually did back in my time as a maintenance manager is I got some breakdowns, real breakdowns, and went back through the whole history of the breakdown. Spoke to the guys that were involved with it, who those spoke to, who was the knock-on consequences and the different people involved, and I put together a long spreadsheet of all the factors, of all the costs, and basically did an analysis, a research and analysis, and came up with these two ratios here. Look, it is nebulous, but it is certainly definable. It is definable. The whole point being is the company will pay everything. Even though we don't see the money going out, the company is going to pay that money anyway. In extra overtime, in sales that could have been made but that weren't there to make, we're going to lose that money regardless. Though it's a nebulous figure, though it's perhaps undefinable, the money is there, and it's just not there to be made now because of the breakdown. So I want to make sure that our managers understand this risk boundary They've got to see the real risk boundary, not the one that they think, but the one the company's actually suffering. Because that number often is a massive number. And that number will justify some big changes and will finance training and finance new machinery and finance new systems. But they just don't see how big a number that's actually falling off the table. And that's the challenge when we talk about plant wellness, is to show the real financial cost. Because until people see where the money is, how much is sitting on the table they could have got, but just can't see it, they won't move. So I've got to force people out of this acceptable range and say, oh, we'll live with that, into, hey, you know what you're actually missing? You're actually missing absolute fortunes in profit.
Are managers inclined to say, well, this is just the cost of doing business. This is the way we've always done it. This is the way my predecessor did it. That's the way I do it.
And I think that's why we know all the answers and they're not being used. We know all the answers, they're just not being used, because I was taught wrong in university as an apprentice. If you learn off the manager in front of you and you do it his way, I'm sure he's taught wrong. This is what happens. We're just monkey follow monkey. That's what's wrong. Yet there are companies that do it so well, we look up to them and say, show me the way. They're all out there, know what to do. I just can't get it to work in my company. And plant wellness is about getting one process, one way only, to make it work in every company. That's the bit, that's the hard part. That's the bit I want. Make this work for everybody, not just for the leaders. Fantastic. I have confidence we can do it because they're doing it. But it's no good to you and me with a struggling company. I've got to find an answer that I can afford. I've got to show them where the money is. They're losing absolute fortunes. That is so easy to get back once you see it. Risk chart is actually a volume, because there are three components in risk. There's cost, opportunity, and reliability, and the chance. So it's actually a risk volume that we're dealing with, not simply a flat chart. So I can control opportunities. If I can reduce that opportunity to less and less and less, if I can reduce the chance of things going wrong, then my volume of losses decreases, and the losses that are not happening become profit that I'm now collecting. So I've got to find answers to prevent opportunities and to reduce risk across the whole life cycle and everybody involved with the machinery. So operations are going to be involved, engineering is going to be involved, maintenance is going to be involved, and finance is going to be involved. I need everybody in the company to understand we all play a part in the success to win back these issues now. Risk, when we chart risk, if we put it on normal type axes, then we get a curve. So risk, if I keep that simple, risk is equal time to the consequence, which is dollars, times frequency, which is frequency per year. If I plot that, so if it's $1 and it happens 100 times a year, my risk is still $100. Or it's $100 times once a year, still $100. So that's how we get these curves from that one equation. We just change those numbers and then we get a curve plotting across our chart there. What's important here is to realise that risk, that curve, is the same risk of the company. So down here, high consequence, that big explosion that blows up the place, once only, huge consequence, don't want to do that. That's obviously going to destroy the business. The trouble is that risk is the same. So if I have a problem that comes back again and again and again, over the years, that cost is the same. So repeating problems that cost a little bit of money but are always there, I'm always fixing those, in the end, as bad as the whole place blowing up. The money goes. Instead of being a bucket of money, it's a little drip. Drip here, little drip there, little drip there. The trouble is the business pays for the lot. So I cannot carry small risks that repeat, because that is a leak. And that leak eventually will drain the business out. If I've got many leaks, I am forever putting stuff in the top to replace what's been leaking out. That was the trouble that these guys were suffering. Half of what they're doing repeats every 3 months. 1/3 every month. They had massive little leaks. They had massive, thousands of these little leaks, sucking money, sucking the blood out of their business. Because the big stuff everybody sees, that's a big problem, we protect against that. they forget about the small ones. And the small ones are as bad as the big problems in the end. So I've got to be careful. No? That's what risk is about. Now, risk is that curve. Anywhere along that curve is the same money I'm losing. If it happens to be one event here across 10,000 events. But I've got 100,000 events happening every day. So I can lose money very, very fast, but a small amount each time. When we plot risk on a log-log scale, we get straight lines. Now, you've probably seen a risk matrix, and they use this arrangement here with the different colours. Comes off the log-log scale. So yeah, we tend to work in log-log with risk because we're talking about big numbers, millions of times, a chance in millions or chance in 10,000 years. So we tend to work with log-log scale, but it comes off the same mathematics. So from our risk matrix, we get our risk graph, we get our risk matrix, and this is the stuff many companies now use in terms of managing their safety requirements. What I'm just saying here is be careful. Here on this sort of matrix, we've got lots of red. Lots of red, of course, is bad, extreme risk. The trouble is that comes from this part of the equation up here. And it's only a small area on the actual graph that is a high risk area. Because we're converting a log-log scale into a linear type representation, it appears as if a lot of things can go wrong because there is so much red. It's a bit deceptive. It's not easy to have high risk situations regularly. You get them exceptionally, but this looks as though many things can be high risk or extreme risk. In the real world, it's unlikely because there are so many things that have to line up in a bad way for bad events to happen. But yeah, this is where this matrix comes from, our mathematics. What we have to be wary of is if we start getting lots of risk scenarios up here, it's suspicious because there can't be that many things that go that badly wrong all the time. They're exceptional, but they do happen. This is an understanding of what we try and do to manage risk. This is the Swiss cheese concept of managing risk. What we know is a hazard out there. If the hazard isn't controlled, there will be a consequence of some disaster perhaps, or somebody gets hurt. So put in place various barriers. Things like trained people, things like procedures, things like instrumentation, documentation, a whole bunch of things you put in place to prevent the hazard becoming a disaster. Every barrier has weaknesses, and the weaknesses are shown up by those holes in the Swiss cheese. Now, the trouble starts when all the holes line up. So when all our barriers that have weaknesses, when the weaknesses line up, then the barriers are then not functional. So that's a particular model that we sort of use to explain we've got to have enough barriers there, and of course we want the barriers with no holes would be ideal. At least the very small holes, and we try and control when barriers are used. So it's a concept of how to manage the dangers in our business and why we do things certain ways. In industry now, there's an acronym, ALARP, as low as reasonably practicable, and it comes out of a law case in the United Kingdom, I think after the Piper Alpha disaster. The judge had a look at what is a risk our community, our society will accept. Now, how far should a company go and say we've gone far enough? Because zero risk would be great, but zero risk is an impossibility on this planet, in this universe. So the judge said, look, go to the level of ALARP, as low as reasonably practicable for your industry. So we then can define what that means, and we get a graph like this, and there's a zone of ALARP. Now that isn't as good as you can be. ALARP is what is acceptable as reasonable to do. Oh, we can do much better. But at least now we have a way of understanding we've got to be within a zone of acceptance of risk. Anything above is unacceptable, and in a court of law you will be found accountable because you have not gone far enough as to what is reasonable to be done. That then gives us a way of rating things, how often problems should occur, and anything more often is unacceptable, and of course the costs of those events should they happen. What we want to do is find a way to drive that risk lower and lower and lower, because the equation before told us if I can drive risk down, my reliability goes up. And reliability is where the money is. So yeah, ALARP is worth knowing about, but I don't want to just sit there. I want to push past that, because the lower and lower the chance of things going wrong, the more profit I will actually make. So when I find a technique, when I find a strategy, when I find a process, when I find a methodology to create that situation. So we have machines and plant and equipment out there that are doing its thing. Whatever we do to that item of plant, we want to make sure it drives reliability, drives high uptime, drives the chance of failure lower and lower and lower. So we might have machinery and assets, and we do things to it. We work on it, we operate it, we maintain it, we engineer it. Now, if I don't get the right balance, I'm actually doing a lot of work that's delivering poor results. We want to be here. What we're actually doing is down there. We're a long way short of where it needs to be. So we go looking for answers. And we're looking for answers that drive this curve lower and lower and lower. So we know already to get this curve to go lower, I've got to stop the parts from failing. So I've got to find techniques here that focus on my parts' failures, the cause of their failures, and then a way to remove that cause. So now what I'm going to do is come to this situation here where I'm doing only what's required. That gives me the maximum reliability for the cost I'm willing to pay. And that's the technique that plant wellness is all about. The process to go down this arrow to find the right things to do that in the end is the least required to get the minimal downtime and maximise reliability. And if I can find that process and lock that into the way my company does business, then I will drive reliability and uptime and profit and success. So yeah, a solution. And I don't want to have multiple ways of doing things. I want to have a process that is universal, that when I apply the process, the outcomes are always the right outcomes. So I want to have a technique that I can transfer across every business, regardless of what the business is, and it will produce the right results for that business. So the right maintenance strategy, the right operating practices, the right selection of equipment and engineering and materials choices. I want to get all that out of my process. So I'm going to put in things like my costs, my business successes and losses, what risks are involved, and techniques to remove stress, because stress is the killer. And if I can find a way to do that and manage it, then I will actually manage reliability. I'll actually grow it better and better every year. So plant wellness pulls all this together into a style, into one way of doing it. There are many ways, of course, to come up with maintenance strategies. There are many ways to run your plant. There are many consultants out there that do engineering their own particular way. My worry is if I let people do things their own way, follow my manager's previous experience, or follow what that company does, or do it the Japanese way with lean, or do it to the European way, then what I'm going to cause across my business world is huge variation. Though we're all doing what we think is right, picking the right strategies and our own techniques, running the plant in a particular way that we think is right. If I'm doing this across the American industry or the worldwide industry, I'm going to get a huge distribution because I'm using many ways to try and find an optimal solution. I'm saying no, don't do that. Find one way. Apply only one technique, which in this case is plant wellness, and that technique will deliver outcomes that are very, very tight around the good results that produce reliability. So though consultants across the world will tell you how to do it, I just think, hey, how do you know you're right? How do you know you're right? What is your thinking that got you to where you are today? Show me the results of your previous work. How successful were your ideas to produce reliability? Because I'm sure many guys will be like that. Many guys will have lousy ideas, some will have totally brilliant ideas. But I can't have a huge range of ways of achieving the right outcome. I've got to have one process. Run that process, and that process delivers the right outcomes every single time. So that's why plant wellness is one process, one concept. So I can now control how we do it. I can train guys up to do it the right way, the same way across the world. And they apply the same process and get a very narrow distribution of outcomes, all of which are where they should be. Our risk matrix, I've grown this now into what we typically see in most companies, a safety matrix or a business risk matrix. Across the top here are our consequences, and we can talk about dollars and cents. We can talk about health and safety, talk about business reputation. There's a whole bunch of factors that we can indicate as consequence. Down this left-hand side here is the chance, the likelihood of failure. Very common approach, many international standards that can give you the same matrix. And so I want to stick with what companies are comfortable with. Everybody knows this in industry. They understand the logic behind it, understand what the colours mean, understand the relationship between likelihood and consequence. So I don't want to reinvent this because this works perfectly fine. But it's not refined enough for what we want to do in terms of managing our situation with risk. So I've taken that same matrix and now added in more columns. I've broken that up into a finer grading, and the idea is to be able to be more accurate with which cell is the risk cell we're currently in. Because in the end, if my risk is too high, I want to be able to see that and say, guys, it's too high. Got to go from here down to there. Any ideas how to do that? Please, let's sit down and work out a strategy to get there. So I want to be able to plot my current risk today, and if that's beyond ALARP, or it's too high for what I want to carry, then I want to say, okay, guys, we're here today. I want to be down there. What do we do? And we begin to put together some solutions. And the beauty of this is I can track the progress. I can say, well, if I do this solution, in terms of maintenance, and this is a transformer, for example, on this particular asset, we're going to say, okay, well, if I don't do any maintenance whatsoever, I've bought a brand new transformer, it's going to sit there until it blows up. If it blows up, what's the cost? I can price that. If this thing blows up and it's the only one I've got, I'm going to be down for 2 months waiting for a spare, and in that 2 months I'm going to lose $2 million, $100 million, whatever the case is going to be. So I can plot here very easily a worst case scenario of doing nothing at all. Okay, can't live there. That's a bad place to try and play the game. I might be lucky. Now this is a risk. Just because I don't do anything doesn't mean it's going to blow up. But the dice begin to roll, and lots of dice start rolling. So I introduce condition monitoring. Well, when I start looking at condition monitoring, that is finding problems, finding the P point early, finding trouble before it becomes a breakdown. That means if I find a problem with this early on, then I can repair this at low cost versus the breakdown. So now that particular strategy moves me that way on the matrix, moves me with lower cost at risk. If I can prevent failure, if I can make sure the oil is clean, there's no contamination, that there's no water ingress, the breathers are in good condition and absorbing all the moisture, then I'm driving it down here. I'm having less and less chance of failure. So on my matrix now, I can say, here we are today, guys, historically, or project the future. If that's too much, then I want to move down to here. Give me some ideas. But let's plot these ideas and actually watch this thing moving in front of our face down to this level here. And so now I've got a way of making very clear where we are and where we want to go to. And each of these will have a particular value and bring some value to the company. So now when I do these maintenance, I'm not doing it because I want to do it or because you want to do it, because the OEM tells me to do it. I'm doing it because it's the smart thing to do for the business. And whenever anybody challenges me in the future, out comes this particular plot and say, well, look, 5 years ago we sat down with this. We're doing these activities on purpose to cause the risk to fall down to here. You want me to reduce maintenance? You want me to get rid of my guys and not do this work? Happy to do that. I'll take that one away, take that one away, that one away. So now the risk that was there, she's back up here. Are you okay with that, Mr. Manager? If you're okay with that, just put your name here, thanks. Here, just sign your name. I'll do it for you, but just sign your name. So yeah, I wanted a visual way that everybody knows the game now. There's no magic secrets. It's all on the page in front of us. And you and I can talk and make choices and see the consequences within a limit. Now, this isn't perfect down to dollars and cents, but cell by cell, if I can get close enough to a cell, then I'm happy with that. I've got a good feel for the situation there. So in plant and equipment wellness, we're going to use this matrix and approach a lot, because it's all visual, not what I say. And of course, we're going to have other guys look at this and say, well, you left something out, yeah? And pick everybody's best ideas up. And can I do this simpler? Can I do this faster and quicker? And yeah, of course you can. I don't mind doing it smart, but I cannot not do it. I've got to make sure that these things are done, because it is by doing these that I'm down here. If I don't do these, I'm back up there. And if you're happy with that, don't worry about it. Just live with it. And of course, if the transformer does fail, well, don't complain. You took that risk. You made that choice years ago and you're living with it. Now that it's blown up and you're down for 2 months and you're going to lose $200,000, $200 million, well, don't complain to me. You chose that years ago. So yeah, this is where risk is very important, because if we don't see the dangers, then we don't understand. And that's the bit I think that's missing. Know the concept, just not applying it at the business level, applying it only at the safety workplace level. That is your business. This here is your business. This one page is how your business reacts and impacts on the business. So I liked it very much because it was one page and we can all see what's happening, because you paint the picture very clearly.